So let's think a little bit more about vectors in R3. A vector in R3 can be denoted coordinate-wise by writing down the distance traveled in the x, y, and z direction. And we saw in our last video you can add two vectors together. That means follow one set of instructions and then after follow a second set of instructions. And they could be scaled or multiplied by constants, meaning keep the direction the same, but just stretch or shrink the length of the vector, or if you multiply by a negative constant, go in the opposite direction. I'd like to do an example. So let's suppose I have a few vectors in R2. So let's say I have a vector v. That's the vector v in R2. It says travel a certain distance in the x direction, travel a certain distance in the y direction. There's my vector v. Let's say I have another vector over here, w. So if I have two vectors, v and w, my question is, what is this vector u that starts at the point that you ended at v and goes to the point that you would end at if you traveled along the vector w? Well, here, I understand vector addition as following one vector and then afterwards following a next vector. So using vector addition, I see that v plus u is equal to w. If I follow the instructions given by v and then w in succession, it's the same as if I initially did the instructions dictated by w. So I can subtract v on both sides. So u is equal to w minus v. Now again, what minus v means is that you scale v by -1, meaning you go in the exact opposite direction of v, and then add that result to w. For example, let's do a concrete example with actual numbers. That helps sometimes. So here's the vector v. That's the vector 3, 1. So there's the vector v. V is the vector 3, 1. And let's do another vector. How about this vector w? We'll call that w. That's the vector 2, 4. So then the red vector that goes this way, let's call that vector u again. So then u is the vector w 2, 4 minus the vector 3, 1. And if you subtract these vectors component-wise, I get 2 minus 3, which is -1, and then 4 minus 1, which is 3. So the picture looks correct. The vector u says travel -1 steps in the x direction, so go backwards 1 step, and then go up 3 steps. That looks exactly like what u is doing. Okay, now let me make a definition. A unit vector is a vector of length 1. So sometimes it's more important to communicate the direction you're headed than the length of a vector. So if the direction is more important than the distance traveled, why not make the length of a vector 1 for computation purposes? So a unit vector is a vector of length 1. Here's an example. Let's find a unit vector in the direction of, how about the vector in R3, 1, 2, negative 3. So now I'm in R3, 3 dimensions. So this vector has a given direction and length, and that length may not be 1. That length may not be 1. The way to take a vector and make it have length 1 is to divide by its length. So here's my answer. I'm going to take my vector 1, 2, 3, and I'm going to scale it. I'm going to shrink it or elongate it to make it have length 1. And to do that, I'm going to divide by the length of the vector 1, 2, negative 3. So we saw how to find length in our previous video. The way to find length is using the distance formula. So the length of this vector would be 1 squared plus 2 squared plus negative 3 squared. That's times my vector 1, 2, negative 3. And this would give me, I think, 1 over the square root of 14 times the vector 1, 2, negative 3. That's a perfectly valid answer, but if you want, you can divide each component by the square root of 14. And now I have a vector that has length 1. That new vector has length 1. So it's a unit vector. Let's do one final example for this video. Let's find a vector of length 2 in the opposite direction of the vector, how about the vector 3, 4 in R2? Okay, so I know how to get a unit vector. I know how to get a unit vector of length 1. To get a unit vector, you divide by the length of your vector. That gives you a new vector that's scaled to have length 1. So here's my strategy. To get a vector of length 2, the first thing I will do is find a unit vector, a vector of length 1. Then I'll multiply that vector by 2, making it twice as long. So here's my answer. A unit vector in the direction of 3, 4 is the vector 1 over the square root of 3 squared plus 4 squared times 3, 4. Now 1 over 3 squared plus 4 squared, I think that's 1 over the square root of 25, which is 1/5. So that's the vector 3/5, 4/5. That's a unit vector in the same direction as 3, 4. So it's the same direction as 3, 4, just scaled. To get a vector of length 2 in the opposite direction, my vector is this times negative 2. 3/5, 4/5. There, that's the answer. And if you want, you could scale this so you could see the actual components as negative 6/5, negative 8/5. There. All right, great.